Quick introduction of myself. My name is Casey Karst. I'm a program manager in the data platform group at Microsoft. I currently work on PolyBase and SQL Server as well as SQL Data Warehouse. So just quick check of the room so I can gauge where we need to be at conversation-wise. How many people have used PolyBase? Okay, a couple. And then how many folks know about SQL Data Warehouse? More. All right, so we'll teach you a little bit about SQL Data Warehouse, and we'll go over what PolyBase is, why I think it's cool, besides the fact that I work on it 6 days a week. So let's take a quick look at the agenda of what we're planning to go over. So I have this talk kind of split up into two 30-minute sections. The first half is on logical data warehouse. So how do you reach outside of SQL Server into ecosystems like Hadoop and use PolyBase to actually read the data, pull the data in, and join that with relational data? So that's about the first half. The second half is using that same technology, how do you use it to load data into a SQL data warehouse? And it's kind of a multifaceted tool, and I would like to kind of explain the choices that we've made, how to use it, what's the right way to think about it in the right product. Does that make sense? And just so everybody knows, I'm not a big lecturer. If you have a question, I would love to answer it. Right now, conversations are better than me sitting here and talking through everything that I want to do. So with that, let's start focusing on the first. But before we get too far, let's talk about the basics. So like, what is PolyBase? Why am I standing here for an hour to talk to you about this feature? PolyBase is I think it's awesome. I actually think it's game-changing if people leverage it correctly in their business. It is basically a T-SQL bridge that goes from SQL Server or a SQL product to Hadoop. And when we say Hadoop here, we actually mean an HDFS layer. And so how that can change your business is really, you can start to use big data properly in your SQL environment. And you can keep your big data where it needs to be in a Hadoop ecosystem where you have infinite storage and you don't have to worry about keeping up with it. And you can keep your relational data in the SQL Server. And when you need to combine those two data sets, you actually can very easily just using standard T-SQL. So we'll talk about real quick, what's the state of PolyBase today? So there's 4 SQL products, right? There's SQL Server, there's APS, there's SQL DW, and there's SQL DB. Currently, PolyBase ships in 3 of the 4 SQL products. So we ship in SQL DW, SQL Server 2016, and APS, which is the Analytics Platform Service. Some interesting things to note is the surface area of the feature isn't the same on every product. And so if you look at SQL DW, which is the top line, we don't support Cloudera or Hortonworks, so we actually can't connect to a Hadoop instance there, but PolyBase can connect to Windows Azure Storage Blob and Azure Data Lake Store. So that kind of gives you a viewpoint of like, okay, we're optimizing for that loading scenario for SQL DW, which is what we're going to talk about in the latter half. But if you look at SQL Server 16, we can support Cloudera and Hortonworks. You can do queries to the HDFS layer. You can actually do computation pushdown. We'll talk about that concept a little later. But it's actually pretty optimized for connecting to Hadoop. And the final one I want to talk about that's interesting is APS and HDI. So how many folks have heard of HDI? HD Insights is another name for it. OK, so HD Insights is a fully managed cloud service that Microsoft offers. It's a fully managed Hadoop instance. And so you don't have to deal with maintenance. You don't have to deal with configurations. You don't have to deal with patching. You don't have to deal with any of the hard stuff that comes along with running a Hadoop cluster. Those tend to be pretty challenging to maintain. Does this make sense to everybody? Just wanted to kind of clear the air and set the scene there. So why? Why did we even build this thing? Question comes up quite a bit. And we noticed a trend happening in the past of just data was fundamentally changing. When an RDBMS was first created, a lot of stuff was just entered by hand or entered by sales machines, right? Saying, here's a record, I bought this, keep track of it. Make sure it's ACID compliant and make sure I never lose this data. I mean, that was the foundation of what an RDBMS is. And then we started seeing this new trend of, well, devices are generating data. And they're generating lots of data. And they're generating data in this weird format of JSON and XML, and we just don't know quite how to deal with that in an RDBMS. So then you saw this rise of Hadoop, right? It started in 2008. Yahoo was the really first one to go after it. And they started using it to just keep web logs, right? It's not relational data. You don't need to keep every log all the time. So they really said, ACID compliance, we don't care about you. Throw it out the window. I just want to get the gist of my data. and I wanted to be able to keep a lot of it. And so that's where Hadoop really came from. So with that, as you saw a huge volume of data start to emerge, you saw a lot of new varieties, and you saw more data sources starting to emerge. And when data was first getting stored, it was all RDBMSs, right? Mainframes and then RDBMSs like SQL Server 25 years ago. And now there's more data storage systems than I can keep up with. And it seems to be growing faster and faster. So that's really what we started to see. And then with that, we have new problems coming up, where traditionally you had a big data warehouse for your entire organization. All the data has to be loaded from all the little periphery sources into that data warehouse. And then you can do your querying and run your business as you need to do. The problem is when you have these large data sets and these large data volumes coming in, that takes a ton of time. We'll go through a demo a little later just kind of talking about how one of our customers ran into this problem. But if you need insights now, loading data is just not the thing you want to do. And so if you limit the amount of time to insight, so how quickly can I query that new data, you have a competitive edge over everybody else in the industry. And so that's kind of the current state where we were, and so we wanted to get around that. So we proposed, let's let T-SQL go straight to the data. If you're going to store the data in Hadoop, that's fine, we don't care. Let's make it easier for you so that you can actually query it using the tools you know and on the cadence that you want to do it. Make sense? Any questions so far? No? Oh man, you guys are quite an audience. So how do we do it? So there's 4 key things I kind of want to talk about PolyBase. The first one is the file formats that we use and how we do that. The second one is scale out. So how do we parallelize the loads? Because Hadoop, as you know, can scale out to hundreds and thousands of nodes. And a little tiny SQL server, or even a big SQL server, is going to struggle to keep up with that. So how do we start tackling that problem? Next is, how do we actually impose some sort of structure to the data? And then finally, how do we leverage all of those resources on the Hadoop side so that SQL Server is not doing it all alone? That make sense? Cool. So let's tackle the first one. So when you install SQL Server 2016, there's an option, a little checkbox of like, hey, I want to go install PolyBase. And you're going to see something funny of, you now have to go download an Oracle JRE. And you say, why would I ever want to go do that? I have this SQL box, and you're telling me to go over to Oracle, your enemy, download a JRE, and put it in here. And that's wonky. Well, part of SQL Server, or part of that is actually due to PolyBase. So it's only the single requirement there. But when you enable PolyBase, you actually start up 2 Windows services on your box. One of them is the PolyBase engine. The other one is the PolyBase DMS. So the PolyBase engine is just another query engine that lives outside of the SQL Server engine. And it's there just to make the connection to HDFS and really deal with the distributed query plane. So in traditional SQL Server, all the data is on the same box, so we've just revved on that for a while. This is actually a fork of the PDW engine, which is used in APS and SQLDW, which is MPP SQL Server. You can think about it that way. The next service that actually starts running is the PolyBase DMS, the data movement service. So this is the service that actually coordinates the movement from Hadoop to SQL Server or SQL Server to SQL Server. We'll talk about that latter case in a little bit. So these 2 services just start running. They're running in the background, and it's actually how PolyBase works. It's not baked into the engine as tightly as it is in SQLDW. So within the DMS, we have this component called the HDFS bridge. And that's actually a Java VM running inside of the DMS. And so that's where you need the Java. And in there, we actually have native client jars for Hadoop that you actually upload. So you set a configuration setting, we upload the right client jars, and we reach out to the specified Hadoop cluster using native record readers and writers. So we're actually pulling some open source technologies in there to make sure that we're actually staying current with how Hadoop is moving. We're actually writing in a source file type that the rest of the Hadoop ecosystem knows so that you can actually have interoperability on the same data, which is pretty cool scenario that we see. Make sense? You guys are so calm. It is amazing. All right. So that was kind of the file format. So you'll notice here on the format side, we support delimited text files, RC, ORC, and Parquet, which are pretty common Hadoop file formats. The one type that we are missing is Avro currently. So just wanted to call that out. That usually comes up. Cool. Any thoughts? keep running then. So parallelizing data transfers. So like I was saying, if we just had a single SQL box, and it was reading a single thread, over to the data nodes of a Hadoop cluster, that's really not that performant in these big data scenarios that we were really designing for. So we had to come up with a way to be more efficient with our data movement and actually some way of parallelizing data movement. So we did that in two ways. So the first one is we came up with an idea of a PolyBase scale-out group. Has anybody heard of this? The people who have heard of PolyBase, have you heard of this? No? Okay. So this is essentially scale-out SQL Server with the specific task of reaching into Hadoop. And so what you can do is you have multiple SQL instances running on your on-prem or wherever you're actually running your SQL. And then during installation, you can actually join them together in the little stored proc that you run on each instance. And you say, one of the compute nodes, I want to go be in the cluster with the head node. You can do that with all of them. You can go up to 64 nodes if you want to. We've seen after 10, improvements kind of fall apart. But up to 10 is a good number of nodes to actually have here. And so what happens is you designate a head node where you actually will submit a query. And then you have multiple compute nodes that are just there to help move data across the wire. We noticed that that was the bottleneck. Not the computation power of SQL Server and not the computation power of Hadoop. There's just a finite amount of time and a known amount of time just to move bits from one system to another. So we needed to have more straws, basically, more throughput of data. And so this is what the PolyBase scale-out group enables. So you'll notice that the head node has the engine. So the queries go down. They go through the PolyBase engine. Nodes get the information about what nodes go to gets passed through the DMS services. And the DMS services make direct connections into Hadoop. So we made this because it doesn't matter what type of query you're doing, you're moving some set of data. And if you're in the habit of moving lots of data, PolyBase scale-out groups make a lot of sense. You can just move data faster, you have faster query times. It's all around pretty good. Exactly. So.
You have to have the same versions of,
No, it's perfect. Yeah.
the same versions of SQL. I mean, are there any requirements on those instances
Yeah.
that
So,
you need to?
yeah. So they at least have to be SQL Server 2016. They have to be domain joined. So that's actually part of how we do authentication is they are on the same domain. They can see each other. That's about it.
So you have like an enterprise and a standard?
No, I see. I think they have to be all enterprise now. I know we did a shake-up recently with the offerings.
Yeah. But if you service pack 1, shouldn't all have the same? That's what I was wondering.
No, PolyBase was one of the few that didn't do it. Yeah, it hurt. But yeah, so you can do a standalone head node, a single node instance, down all the way through the stack. But if you're doing a scale-out, they deemed it a enterprise large feature, and it needs to be as sold as such. I didn't get much of a say in that argument. I like it everywhere. Yep.
I got HDI as a pass. Now I got SQL 16 as a meta store, high meta store. So this PolyBase scale-out group, I need to attach a part of the deploy in the cluster, or how we are going to achieve this?
Tying into the Hive metadata store? Yeah, so PolyBase today doesn't tie directly into the Hive metadata store. We'll talk about external tables and how we actually put schema over the external data. It's very similar, but we don't actually take metadata from the Hadoop system. You actually go down to the file directory level and you specify, I want to reference this set of data as this external table name, rather than saying, go to the Hive metadata store, pull in all that data, and then I can reuse those table definitions. It's something that we're definitely looking at in the future of, I would love to think, my biggest goal with a lot of this stuff isn't to make us indispensable. It's just to make us so convenient nobody doesn't want to use us, right? And so like if we can tie into people's metadata, because ADLA has the same concept, right? Where you can create external tables. We should just be harvesting all of that metadata and making it easier. It's not currently done, it's not currently funded, but I've been pushing hard on the engineering team to start thinking about that process. Yeah, no problem. Any other questions? This concept's kind of strange sometimes. Yeah.
I have a question, as looks like that it's a mixture of SQL Server and Hadoop. So let's say if you have to maintain some integrity constraint, integrity constraint, some constraint, differential integrity.
Okay.
Let's say one table, the master table in primary key in SQL Server.
Yep.
The reference integrity.
Yeah, so
Any tools that you have got that we can mention that one. For example, like if you define a foreign key, specifically pretty much say that this is the foreign key you create on that column,
Yep.
which is reference the primary key of some
yep,
action
yep.
of the table. So like how would you go to mention this one, for example?
Yeah, so that's a great question. So how would you deal with constraints and references of data spread across the ecosystem, right? If you're saying, hey, we're not just SQL Server anymore, we have Hadoop as well, how do I deal with that kind of paradox almost that's starting to approach? And the real point is it's hard. It's actually very hard because Hadoop doesn't play by the same set of rules. They don't care about most of the stuff that RDBMSs have been claiming is important for years. That's why they're not ACID compliant. That's why they don't have this foreign key, primary key business. They just don't care. And
So like even we think about like SQL Server and Oracle. Listen,
Yep.
heterogeneous system or Teradata. Just when I work with something like that, I have got a data warehouse system where I have got the analytics or all those things in Oracle still,
mhm,
but the data processing here is still running in Teradata.
okay,
So what we have classified in a way that we won't keep any constant like that.
Yep.
That it will maintain something like that. Okay, it depends on something on Oracle database and we didn't work on Teradata. So whatever we have, but we upload on fact table in whatever ETL it is in Teradata.
mhm,
Then after that calculation, we push that in Oracle system. So we maintain everything constants in Oracle.
Yep.
So like yeah, that's the way that we can do it. But again, like as far as I have about the Hadoop, it's totally different way. It's like conventional RDBMS. It doesn't put the data in a structured way.
yeah,
We just put in a file system, or we just get the data from web page or website, or pretty much unformatted way.
Yep.
So even the database engineers, you have to pretty much do a lot of programming and coding on that just to
yeah.
process it.
And we'll talk about that a little bit in the SQL DW case, but we can talk about it here. Of like the scenarios I've most commonly seen is you have a bunch of raw data just flying into Hadoop, and they're just writing it into this raw, unformatted way, and then they have known cleaning jobs come through, and they actually cook the data into some flattened format that you can use. And this is where you do the data quality checks and make sure if you do have a foreign key that you can kind of check reference tree and say, is there data there or not? Is there anything outside of my ranges? You do that within Hadoop using Hive or Pig, and then you write it into structured streams so that PolyBase can actually pull it out and reference that data.
Because before I had that idea because we are working with heterogeneous system,
Mhm.
but not this one. Like you are putting the same stuff, like totally different architecture. Hadoop and SQL are pretty much what can I say in the same platform, something like that.
Kind of, yeah.
But isn't these technologies meant to be just to have data currencies, like give you the ability to have the most recent up-to-date data via stream analytics and stuff like that? So what you do is that you load this stuff into HDFS.
Yep.
What you do is that one will allow you to have very up-to-date data, and then on top of all that stuff, what you do is that you do data transformation to bring into your data warehouse into your whatever model, your global AMD model, doesn't really matter. And then that's where you actually have all that referencing and reinforcement instead of doing ETL.
Yeah, let's talk about this when we get in the demo, because we actually have a real live customer use case and it might explain a little bit how people are using it effectively out in the wild. So back to the scale-out cluster business. So this is kind of what a scale-out cluster looks like when it's connecting to a Hadoop instance. And the orange threads there are actually reader threads. And so each node in the scale-out group has 8 threads. And so as you start to expand it, it scales out linearly, and you have linear improvements in performance. And so each thread can actually read a file in HDFS independently. If the file's too big, it gets split up into 512 megabyte chunks, and then the next thread can actually start reading it. So that's pretty optimized for actually moving data from the data node layer in Hadoop up into SQL Server where computation can happen. Does that make sense? All right, so this kind of gets to the external table discussion of how do we actually put structure over that data living in Hadoop. So Hadoop is based on a file system format. You have multiple directories, and the directories at some point hold files. Hadoop? No, you can export too. Yeah, we'll do that in the demo. So PolyBase can actually do 3 things, and you think of it as a generic data movement as well as querying. So it can import data, so you can just pull raw data and land it into SQL Server or SQL Data Warehouse. You can do computation push down, so you can actually write a T-SQL query and push it down, and it creates a MapReduce job, and then you can pull the result sets back, and then you can also export. And so the demo that I have actually does all three, because I just kind of like to show the syntax of it, how it works, how to think about it. But to create an external table, to create something that you can reference using T-SQL over your Hadoop data, you have to create three objects. Three objects. The first thing is this external data source. It's basically the object keeping the pointers that actually describe where the Hadoop system is. And so the Hadoop cluster is laid out with a name node, which is the location. So you have a name node, IP address, and port. And there's a thing called the resource manager, which is where you can submit MapReduce jobs to. And that also has a IP address and port. And so these are, publicly referenceable. Each version has slightly different ports, but the IP addresses are just the IP addresses of your machines. And we can look at that if people want to after the talk. And then you have to tell SQL Server what type of file format am I dealing with. And so this one is a text file with pipe delimiters. And there's quite a few options that you can actually put in there. We have it all documented on MSDN. But this one's just a pipe delimited text file. So it's nice and easy, makes it easy to actually read during demos. And then finally, what you end up doing is you say, create external table, and you give it a table name. And then you have to define schema. And so PolyBase is strongly typed. And so make sure that the schema is correct. You actually give it the HDFS file location, which is this value here. So this is specifically saying which directory and which file do I care about. PolyBase has a feature called recursive directory traversal, which essentially means if you point to a directory and it has children directories underneath of it, PolyBase scans every directory for every file. And so you can use that effectively to say, what range of data am I actually interested in? And we'll talk about that in the loading piece a little later. And then you just pass through the data source and file format in your external table definition. And now you have an object in SQL Server that you can run a query over. And you can run a select star, you can run aggregates, predicates, whatever you want. All T-SQL language actually works with this table. So that's a pretty powerful thing, because now the data is no longer living within SQL Server, it's out in Hadoop. But I can treat it just as if it's local. The only difference is there's a slight performance. It's slightly less performant because you have to move the data across the wire. Yep.
If you create this external table right now,
Yep.
So like when you create a table, it certainly uses a database engine. So what database engine is used here when you get the external table? Is the Hadoop engine being used?
No, that's a SQL Server. So this is all in SQL Server.
It's on SQL Server.
Yep.
This looks like pretty much Oracle. You can get back to Oracle. We also create external table.
Yep.
Flat file, pretty much. So, like, if something like that, then what's the difference? Like, if Hadoop is just having a different engine, and I'm creating the external table on a flat file, so what's the benefit I'm getting here?
From doing this?
Yeah.
It's if you want to join the two data sets together and you don't want to do these bulk loads. And so we see this really commonly in Perfect. Awesome. So the scenario that I was going to talk about, and this is what the demo's on, is we have a large insurance customer, and they realized, a car insurance customer, and they realized car insurance is somewhat unfair to their customers, right? It's all statistically based, and they look at somebody like me and they say, hey, you're a young guy, you're a very risky driver, because we know from past young guys that they're risky drivers, we're going to jump up your insurance premium. They don't know that I drive a super slow car, and I don't drive very often. But they assume, based on their statistics, that I personally am a bad driver, and they didn't have a better way to do that. And so that creates all sorts of interesting business problems. I'm not loyal to them, I don't care, et cetera, et cetera, et cetera. But they said, we have to find a better way to do this. We have to have a big data solution to actually make this better. We need to know how this person is driving. And so what they did originally is they came up with a pilot program. You'd plug a sensor into your car, and it would start emitting data about how you're driving. What's your G-force? What's your acceleration? Did you slam on your brakes at the stoplight? How far do you actually drive? You know, when you fill out the form, I don't know if it's the same here, but like, you have to fill out a big form whenever you sign up for car insurance. How far do you drive? How many kids do you have? How much money do you make? And they pull this all into a statistical model, and they say, okay, whether or not you're risky. But it has nothing to do with how you drive, right? I always thought that was kind of funny. It's like, I could lie about the form, and it'll make a difference, but I can still drive like a crazy man, and they'll never know. But they came up with a sensor model. They came up with a big data solution to make it better. So what they did is they put the sensor in your car, they start collecting data, and they say, we'll give you this base rate, and then we're going to change it in a month. We'll track you for a month, and we'll figure out how you drive, whether or not you're risky, and we'll change it. So that was their first generation. Their next generation is actually using the app on the phone. So the phone actually emits data, which is pretty cool. I don't know if they do that here or not, but in the US, that's what they do. A little scary, but that's essentially what they do. But how they have the setup actually broken up is they have all of their relational data. So everything about you as a customer lives in SQL Server, and all of that sensor data actually lives in a Hadoop cluster. And at some point, you have to join those two together and figure out who's risky and who's not. So that's how they're using PolyBase. They just don't want to have to load every sensor record ever just to adjust one person's claim. So does that answer your question a little bit? Kind of how folks are using it, what you get out of it?
Yeah, that's fine, but I was talking about external data.
Yeah. It's just a method. It's just a method for doing it.
External data pretty much looks like nothing to do with the Hadoop. It's something like SQL Server stuff.
Yeah, you just have to have an object that you can actually reference using T-SQL. And that's what all those objects really were, is how do I make a connection to Hadoop? It's one way or another, and we thought external table would be.
It's just a schema in SQL Server pointing at Hadoop.
Yeah, it's almost a view. It's,
Can I ask you a question? The difference between Oracle and the Hadoop is the file which you got is distributed on HDFS, whereas in Oracle you got only one directory. Whatever directory is there, the file is there in that location. Whereas in HDFS, the file is being distributed on HDFS. It's a file system. It's a file system. It's a file system. It's faster than the Oracle.
But it's a true external table definition pointing to PolyBase thing rather than actually, so that's the engine that actually
the external table definition is pointing to a file or a directory within HDFS. The engine takes care of all the routing for you. You don't have to know that piece.
isn't that a subtle difference? Because you could have other external tables that are not pointing at that, but all they all point up.
What was?
An external table in 216, are they all through PolyBase engine or are they?
No, they're not all through. The syntax is all the same, but they're not necessarily all using PolyBase. There's a few other technologies under the hood that actually are used. But we made sure that the syntax remains the same for external table. Anytime you're referencing stuff outside of the database, unless it's a linked server, because that one's a bit older.
You've got external tables, but then you say look at text files locally or something like that.
I don't believe you can look at text files locally with it. But yeah, but there's some cross-database query and things like that come up. So with a quick demo, just to kind of get our feet wet and get an understanding of it. I have a table locally called insurance customers, and I have a table within my Hadoop cluster that's their sensor data. And so there's a key to join the two. And you can kind of imagine that we're trying to figure out, we have some questions about our customers. Who's driving fast? Who's driving slow? Whose rates do we need to change? And then let's do some archiving. So I'm using the correct database, so I don't have to change that. So just so we all get a quick understanding of what's in the local table, we have a customer key, a first name, last name, gender, yearly income, and commute distance. This is all the stuff that we've had to fill out in those basic forms. So you'd keep that locally. You can actually put security stuff on it. You can put RLS on it. Put all the SQL Server security that you need to keep your customer data safe. You can do that within SQL Server and not worry about having to deal with that in Hadoop. The next thing that you do is you run spconfigure, which basically tells PolyBase engine which version of Hadoop are you running against. In this case, you guys are getting the first sneak peek at Cloudera 5.10. It's not officially announced, but we ran through the tests since I've been in Australia, and everything looks good, so I wanted to let some folks know. So it's not officially said yet. I have to go home and change the documentation, but as far as I'm concerned, we're good to go. So we keep going, and so we'll create an external data source. I've already created these, so we just kind of look at it for syntax real quick. Again, you have the name node IP address and port ID, and then you have the resource manager, IP address, and port ID. And then we actually have all the DMVs plumbed into this so you can keep track of this stuff programmatically if you wish. So you have sys external data sources. You can go through, and it keeps track of all that information. So all of that's kind of plumbed in as SQL Server. We'll keep going. We create an external file format, and this one's pipe delimited as well. Nothing special here. It's just describing the data that we have in Hadoop. And then we create this external table. It's called sensor data. We have a set of schema, and then here's the directory that we're concerned about. And so we can run a quick select statement on that. There we go. So we just imported all of that data from SQL Server into from Hadoop into SQL Server. There's only a select top 10. We can also do a select star if we want, and it would just pull the whole data set in. And just to prove I'm not lying, we can go over to Hadoop. So it pulled 10,000 rows in just now. So the reason that first one took a little bit of time was making that first connection. I had to start up the connection. But after that, they're significantly faster. Any questions? Thoughts?
When you back up the database, does it include the external tables?
Should include the external table definitions, yes. I mean, that's all that's actually stored within SQL Server. So it's the metadata pointing out. So here's that file directory that we were looking at in Hue. So you see a set of files. And we can take a quick peek at the file format so you guys can understand the pipe delimited. And so that's the same data. We just reached out, pulled that into SQL Server, and had immediate contact with it. Which I find, pretty cool and fascinating. Yes?
Like the table that has been created in Hadoop, we can also see this is display browser here, right? Just under this, what is it, AU Ignite?
Yep.
Under AU Ignite database, the section also comes here.
Yeah, it's right there. So it's in the object tree. External tables, external data sources, and external file formats are all on the object tree.
If you think of the performance perspective,
Yep.
Like index, statistics collection, all those things,
Mm-hmm.
how are you going to do that through Hadoop, like this head of table?
So you need to create statistics on your external data, but we don't have a concept of indexes on that data. And so you can start to play with the way on the level of, we can talk about it. Let's talk about that when we get to SQL DW. I don't want to spend too much time here, but if you deal with the file directories correctly, you can actually do quote-unquote partition skips, that idea. There's a common year, month, day paradigm for creating directories. So if you don't need to look at the entire year's data, you focus on what you do need to look at, and you've effectively cut out a large set.
From Hadoop perspective,
Yep.
like as you said, there's an index concept there. Like as you know that if you think of early units conventional, there was index partitioning, table partitioning, list partitioning, partition sorting, just to enhance the performance.
Yep.
You don't need to browse or scan the unlocked
Yep.
data. Like
Yep. And so, we'll talk about it in just a second, but there's two ways that PolyBase works. One is streaming the entire data set back and letting SQL Server actually do the computation. And the other one is tearing down the SQL statement that you wrote, turning that into a MapReduce job, and submitting that to Hadoop. And so that actually is optimized.
That's the beauty of it.
Yeah, exactly.
In Oracle world, it will reduce take a lot of minutes to load a content.
Yep.
so with PolyBase engine has a little bit query, it's hard for me.
Yeah, exactly. So that's why you create statistics. I mean, if it's multi-terabyte and it says, whoa, 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 this is going to take a while for me to move this, let's push that computation as much as we can. And it's cost-based, and it happens behind the scenes. So I force it, and the demo's coming up. But I want to keep moving a little bit, because we're actually getting a little bit behind, unless you guys are willing to stay out of the party to keep going. So you can see here, this isn't necessarily the most complicated query in the world, but we have some interesting stuff. We have an inner join, we have a predicate getting pushed down, and we have column filtering, all happening within the same. And we're actually joining that external data with our local SQL data. And we're getting that insight that we needed. Say, hey, who's driving faster than 65 miles an hour? We need to bump those guys' rates. It's just like that. You now have that data, and you now have a list of customers that you can go do that with. This is not a real data set. So if you see your name here, it's purely by accident. All right, so that's where we're going to stop for now, and we're going to do a quick jump back to explain our real differentiating value, which is how do we exploit Hadoop and make sure that Hadoop actually does some of the heavy lifting for us. And so there's a concept that we like to talk about called predicate pushdown or computation pushdown. So how does that work? So you could imagine you'd run a select statement like this over here, where you're selecting a subset of the columns, and you have a set of predicates, right? And this is the table that we're actually querying. So the first thing that we do is do a dynamic binding to the table. So we say, this is a table, and it does exist. Then you push down the column filters. Then you start pushing down the row filters. And so instead of importing this entire table, we actually just import those three entries. So this actually greatly reduces the amount of data coming across the wire, which is our ultimate goal. How do we make stuff performant? You minimize data moving across the wire. That is the biggest thing that PolyBase can do. And so That's kind of on a high level what's happening. On a deeper level, SQL Server can do column projections, limits, predicates, partial aggregates. We don't push all of them down. And we do not do joins, just kind of flatly. Hadoop struggles with the idea of a join. And if we push local data to Hadoop, we've actually just bypassed everyone's security models. So we chose explicitly not to go down that route. And you'll see here to Azure Blob Storage, there's no across the board. And so the reason for that is Azure Blob Storage and ADLS don't have a computation engine that we can talk to today. And so we can't push down to anything. And so that's why we think of SQL Data Warehouse, PolyBase and SQL Data Warehouse, just as a loading tool. Because if you're running ad hoc queries over terabytes, you're loading terabytes every time you run a query. It's much better to load it into SQL Server or SQL Data Warehouse. Then you can run as many queries as you want. It's all local and all optimized. That make sense? That's been a tricky point for us in the past. So let me jump back, and I can kind of show you how the federated queries work. So over here, we have that same query. And now we have a query hint that says option force external pushdown. So what this does, and it takes a bit more time because this is a small data set, but on a larger data set, it actually pays off. What's happening is we submitted that T-SQL statement. The PolyBase engine looks at it, saw the query hint, passed it over to the resource manager within Hadoop. It spun up a MapReduce job that takes 16 to 20 seconds just to spin up the nodes. It's a batch-based system. And then we get the result set back. And so if this was a larger data set, it would actually pay in spades to go this route. And luckily, the query optimizer knows exactly what happens there. But I just wanted to show you that is a differentiating feature for PolyBase as opposed to some of the other external data tools. And then to get to the gentleman's point earlier, so if we wanted to do a point, you can do a select into, an import. So you do a select top 5% of fastest driving customers into my local table. These guys are going to get an email tomorrow, right? Hey, your rate's hiked. You're in the top 5%, I'm sorry. And so we just imported that table from our external data source into the internal. So now we have that. It's just that easy, so we can start moving data around and dealing with it how we need to do it. And then if we were going to export, it's actually pretty simple. So you create an external table with a directory that doesn't exist. And it actually goes and creates the directory for you in Hadoop. And so what we did is we just created a blank directory. And we just created some object. And of course, I already have it. In a second. That's what I get for running through my demo before the talk. The PolyBase engine doesn't push local data down on a join because of security concerns, but we're assuming that the admin knows this data can actually go there. You actually come up with a great point. So we're going to throw an error message in a second, because it's not turned on by default. You actually have to override the SQL Server configuration saying, no, like I'm okay moving this data. We did that for two reasons. The first reason was exactly as you said, that security concern. The second reason is Hadoop doesn't play by the same set of rules SQL Server does. It's not ASM compliant. We can't guarantee that all the data that you're writing is going to be written in the sink into Hadoop. And so we just try to make it explicitly clear that you're leaving the SQL ecosystem. The data is now outside of our control. So yeah, exactly like you said. If I try to run this insert into, it'll barf and say, hey, you need to flip this flag. And so I say, allow PolyBase export. I set it to 1. I run that. I reconfigure my configuration settings, and now I can actually export. So I just wrote 238 rows to the new directory within Hadoop. And so you can just move data back and forth, or you can do the ad hoc query. That make sense? So that, yes. And then you can also continue to query that data. So we created that external table. The reference still exists within SQL Server. Now we can read those 238 rows back into SQL Server whenever we want to. It's not like you're stranded without that data anymore. You still have the reference. So that's the end of the first half. Yep. It does not write the headers, no. No, that's something that we're looking at, and we're actually looking at the ability to skip header rows as well. That's not currently there. But yeah, so that's the first half. We're 10 minutes slow, but that's fine. We can actually move through this pretty quickly. So we're going to talk about SQL Data Warehouse for a little bit. So for the folks who don't know about SQL Data Warehouse, it's Microsoft's MPP SQL Server in the cloud. So it's massively parallel processing. It's for large analytical workloads, specifically designed for the cloud, fully managed for you, so you don't have to deal with patching OS, patching SQL Server. It's all handled. And so you'll notice that this architecture looks pretty similar. It looks like the PolyBase scale-out group, because that's where actually we took our inspiration for the PolyBase scale-out group from SQL Server MPP. So you have a control node and multiple compute nodes. And within that, you have the DMS, the data movement service. And with that, you have the bridge, very similar to the PolyBase scale-out group. So how people traditionally load data into data warehouse is with the single gated client. Think SSIS, BCP, anything like that, right? And so that writes a row of data, it hits the control node, and then we have to distribute that data to the compute nodes. So the perk of the MPP system is the data is actually distributed across the compute nodes, and so that forces parallelism on every query. So the number of nodes that you have, each node is going to run the query on the data that it has and then push the result sets back up to the control node. And so that's part of the performance gains that you get from an MPP system. A colleague of mine is actually doing doing far more justice than I can to the MPP system tomorrow morning, I think at 8 o'clock. So if this is interesting and you kind of want to know more about it, please go to that. But this one's specifically talking about the loading piece of it. So SSIS or anything like that will have a single gated client. It writes a row. It then has to go and find the right compute node. That takes a bit of time. So the bottleneck is really the control node. And how client-side folks try to fix this is say, hey, let me just write more data. Like, I'll write it faster. The client node will figure it out, or the control node will figure it out, and we'll write it to the compute nodes. But you haven't solved the fundamental problem that you still have this bottleneck on the control nodes. You have to figure out a way to solve that. And so where PolyBase came in is, since it's actually built into the engine of the MPP environment, PolyBase just goes control node straight to WASB, so Windows Azure Storage Blob. And this is how we're the fastest loading tool within Azure right now, is because we have massive parallelism on the compute nodes, and then we have parallel reads within each node, very similar to how we connect to HDFS. In fact, we actually use the same APIs to talk to Windows Azure Storage Blob. They actually present a Hadoop API layer on top of Windows Azure Storage Blob. So 2 weeks ago, I would have stopped here and said it's over, but then we just announced that we actually support Azure Data Lake Store. I know it's not in country yet. I've been hounding their PM to figure out when it's going to be. I've heard from several folks that this would be a great thing to have. But yeah, so we have the same functionality on Azure Data Lake Store. You can just basically connect directly to it, pull it in by directory using external tables, so you can load data from your common data store. Cool. And then just a quick by the numbers. So I stole this directly from the Azure Data Factory team. On the left, you'll see cloud sources, and on the top axis, you'll see data syncs. And so if you look at the Azure Blob storage to PolyBase, it's 1,250 megabytes a second, which is about 4,000 times faster than bulk insert. And then if I remove the blinders from everybody, it's actually an order of magnitude faster than the closest competitor. So this is really why we wanted to focus on PolyBase being a great loading tool, because it's technically built for it. It's just we have a couple little nice usability things to add to it, and then it's the best there is on Azure today. So yeah, so I just wanted to show you that real quick. And then how are folks using SQL Data Warehouse? And this is kind of how they're using PolyBase just in general, but it happens to be that instead of SQL Server here, it's actually SQL DW. So you have a bunch of data coming in, landing at ferocious rates. I mean, we have a couple customers coming in at 10 terabytes an hour, 10 terabytes plus an hour. It's staggering who can generate so much data, but they do. That all lands in some common data repository, either Azure Storage Blob or Azure Data Lake Store. And they do these giant batch-based processes to clean the data, to throw out the dirty records, to actually fix it up, make it into a flat tabular model so that they can import it into SQL DW. And then you use PolyBase to do the load. You do a final transformation within the data warehouse, so it's definitely an ELT scenario rather than an ETL. They do the final transformation using the MPP resources that they have. And then they do batch-based analysis within SQL Data Warehouse. That's the most common and the best practice that we've seen. Does that make sense? Just kind of an overall Azure flow. Cool. So what I'm going to try to do, I don't have time to do the full demo, but what I'm going to try to do is start to build out a data warehouse in front of you guys. It's a 50 gigabyte data warehouse. I I can at least load all the data. I might not be able to clean all the data in the time that we have, but we can get started at least. So the quick overview of what the data set is, it's actually the New York City taxi cab data set. It's publicly available, really fun to play with, get a lot of funny insights. But I basically have one large fact table with 170 million rows and then a bunch of dimensions. And none of the dimensions are larger than just over 500,000 rows. So a good chunk of data to actually play with. I try to do real-ish demos. It's very easy to do a little snappy one with the mega data, but this is about 50 gigs, and it's actually coming all from Azure Data Lake Store. So I'll skip that, and we can talk about it on the fly. So hopefully I'm not going too fast for everybody. It's just I have a tendency of overpacking my talks. But there's going to be great moments for questions coming up, because moving data always takes some time. So the first piece, so I've already created the external data sources, and I've already created the external tables. I'm just going to start loading the data. So these are all of my dimensions that I'm going to load. They're relatively small, so I actually don't have to worry about any load resiliency or anything like that. I can just create the syntax within SQL DW or PDW is create table as select, as you'll see. And then within that actually definition, you actually also go and you go ahead and create the index, and you go ahead and create the data distribution. So data distribution meaning, how do I want the data written to the compute nodes? Do I want it to be round robin distributed, which is basically as evenly as the loader can actually distribute the data? Or do you want to hash the data on some key? So that there's some reasons to do that. I'll leave it to Matt tomorrow to actually discuss in detail, if you guys are interested. And just a moment. There we go. So I just kicked that off. So it's going to go ahead and start loading that data. Not a considerable amount, but it takes about 30 or 40 seconds to actually load this. Any thoughts, questions, concerns? Did I lose you guys?
No, the only thing, sorry.
Yep.
Not related to this, but some unkind people are saying that HDFS is, on the way out.
Who's saying that?
On the internet.
Okay. They're always right. I don't think HDFS is on the way out. I truly don't. I think it solves a problem that a lot of folks have. I think what they're seeing is it's not as growing as quickly as it used to. And I think that's just the nature of the beast. They were hot stuff a couple years ago. They had tremendous growth. It's wonderful. But they are starting to slow down. And it's really, you have the big three, right? You have Cloudera, Hortonworks, and MapR. And they've been duking it out pretty hard for the last couple years. And I think you're starting to see them shake a little bit. But I've seen some very large Hadoop instances and customers very happy using them. I think people are also finding out you have to be a certain size to use Hadoop. You don't put 10 gigs on Hadoop. You don't put 50 gigs. It's tens of terabytes actually is when it starts to shine. And so they had a great sales team early on, and they sold a lot of instances that weren't necessarily needed. Yep.
My follow-up question is, do you see sort of extending PolyBase to other technologies like Document DB?
Yeah, so I intentionally didn't include it. We are working on that. We actually are. We've done a lot of work on it. The only issue is we don't have a defined known shipment vehicle. And so in transparency, I try to not talk about stuff I'm not sure is going to come out in the next 6 months to a year, just because I don't want to get people's hopes up. I don't want to have you run off and design something that's going to be great and then we don't deliver. So I generally try to hold that stuff close until we get closer, until I have high confidence it's going to ship. And then I'll be more than happy to explain it and go deep into it. So the next thing we'll actually do is I wrote a little script that actually loops through the file directories within my Azure Data Lake store. And so I have a directory set up of year, month, day, and I have a year of data. So what I do is I actually go through and I dynamically create the location within ADLS, and I load a month of data at a time. So I'll kick this off. It takes a couple minutes. I'm getting errors because my computer decided it didn't want to connect. But we'll kick it off. Awesome. And so you're going to say, like, why are you looping when you have this great loading tool that loads quickly? I would ask that question, and I'm going to ask it for you guys. The reason I want to do that is it's in the cloud. And stuff in the cloud, you have to build resiliency into what you're doing. We do it with connection strings. We do it with loading. It's just kind of how you have to think about it. Stuff is moving around. We're load balancing for you guys. We're making sure you get updates. We're patching, doing all of that. So when I think about how do I want to make sure that 9 hours into my 10-hour loading job, I don't fail and roll back my entire loading job, I break it up into chunks. And so for this example in particular, I said, hey, a month is a pretty good chunk to actually have. And so I know that I can create a new external data source pointing at a specific directory, load that set of data into SQL Server, and then I can drop the connection. So if anything happens, I have a stopping point. I know everything before that's clean. I always wish I could inject a failure, like right when I say that, and then actually roll it back. But
Sorry, you lost people with the
yep.
first two scripts you ran, they were populated, the first script populated the dimension table, the second script populated the fact table.
Yep. So I created an...
Pulling it directly from Azure Data Lake and into your
Yeah, so let me...
data warehouse, and what is this?
Yeah. So this fact table, which I actually don't think I ran, is just a blank fact table. And so what I'm actually going to do, and we won't get to the full depth of it, is I was going to do partition switches. So pull in each month of data, and then you transform the data into partitionable slices, and then you do partition switches into this main fact table. It's a pattern that we've seen. It's not the only pattern, but it's a pattern that we've seen. Little rush for time is the only reason I didn't talk about that specifically. But the interesting part is once this is complete, it takes about 3 minutes, we've loaded that 50 gigs. This is our last loading piece. So this script loads monthly. We've created our empty fact table that we're going to do partition switches into. The next script will be how do we actually switch that data in. Exactly, yeah. So you actually see those tables on the left. It says 2013-01. That is January's data for that year, for that table. You can see we're on August. We'll be done shortly. And that'll be the entire loading process, nice and clean. We have a good track record of where the data is actually coming from and where it's getting written to. Should be about done. Any other questions?
PolyBase scale out of your PolyBase engine is in the head node. So
Yes.
when does the throughput between compute nodes and head nodes typically become the bottleneck?
So like what number of compute nodes? Is that the question? Or yeah, so we've seen near linear scale up to 10 nodes. After 10 nodes, the performance kind of bottoms out. And it's because each of the data nodes is pulling in each of the compute nodes is pulling in so much data and then funneling it to the head node. The head node starts to struggle to actually ingest that data volume. So we read at about 80 to 90 megabytes per second per node. So multiply that by 10. I don't want to do math on stage. But yeah. Awesome. So that completed in 3 minutes. We loaded the lion's share of that 50 gigabyte data set in 3 minutes. So it's up, it's ready to go. There's a bit of overhead with splitting the loads, but you get a bit resiliency because of that. That make sense to everybody? Yep.
The entity system, like message browse process, the thing that we are adding some computer nodes, this is we can go up 10. So my question is that, like, if we need more space, let's say disk storage, do we have to add a node, or simply we can add this to this node existing?
In which product specifically?
I'm talking about this, for the parallel processing.
Yep. Okay, so SQL DW.
Yeah, DW.
So SQL DW actually has up to 2 petabytes of storage. And you don't have to do anything. So yeah, so the compute and storage is actually separated in SQL Data Warehouse. There's a concept of a DWU, which is Data Warehouse Unit, and it goes from 100 to 6,000 today. And so you can scale up and down as you need to, compute-wise. Storage remains the same.
So it is like pretty much I can add storage as much as I need, right? Something like that.
You don't even have to think about storage. It just happens. Yeah, it's magic. It's wonderful.
What about this, like CPU or something like that? It automatically adds like.
That's all tied within the data warehouse units. So you scale up your data warehouse unit from 100 to 6,000, and that ties basically all of your performance characteristics in it.
CPU, IO, and
Yeah, it's all tied in this. Yeah, because
Slider, only you have to slide it.
yeah,
When
there's,
you are sliding it, only the queries will not be executed properly.
Yep.
when you allocate your DW, it's just maximum size. So I think you've got to get used to benchmarking and adjusting all those extra units and understanding what it is and
Yep.
getting your
yeah, it's
And like, is it like that if I use more, I have to pay more in terms of license, something like that?
well, it's not licensed. It's per hour. It's per DWU hour. So
Because it looks like, let's say, like for January, let's say, we are processing more data.
Yep.
We may need to make more process or more storage.
mhm.
Or let's say in the middle of the year, we don't need that much CPU, but we need more storage.
Yeah. So we do it per hour per DWU. So like the max DWU you are in for a given hour. But you can scale on the fly.
Right.
And you can also pause the service. So you can actually detach the compute part of it. You don't have to pay for that anymore. You just pay for your storage. And storage is cheap in the cloud. And so that's the wonderful flexibility of the cloud right there. Of, hey, we need to do this peak month. Every month we know we do a job that takes 2 days.
Because
that-
if you think the physical servers, like which is used pretty much 20 years, 10 years, it's still right now it's being used. It is like physical server. So let's say like for some solutions, DW solution, you can't buy the storage. You have to buy the whole node, like
Yeah.
with CPU and everything. It's not like that. You need some. Let's say you have need to extend your data with DW by 2 terabytes,
Yep.
but you can't add a storage. You have to buy a node.
Yeah, that problem solved in SQL DW. You just keep writing it until you get up to the petabyte limit, and we're looking to lift that.
Sometimes like your storage is fine, but you need CPU.
Yep, and so that's why we actually split the compute and storage. So you can scale up, you can scale down as you need to. Start the connection. So we've done all the loading, so at any point we can kind of stop and just kind of talk about it and answer questions, but I might as well keep this running in the background as my connectivity breaks. I think I lost internet. But one of the practices we would do is you load the data into SQL Data Warehouse, then you transform it into the final model that you need to, and you get it into your production tables. And then you can do your batch-based analysis on it. My computer is being flaky, which is okay. So we can just transition out of the demo. That's fine with everybody else? Yeah? Okay. We're running short on time anyway. So yeah, some considerations. We talked about them. Resiliency. Really work with what granularity of the directory structure do we need to worry about? Is it daily, monthly, yearly? How do we tie that in with resiliency too? Of how can we loop through this to do several medium-sized loads rather than one giant load? And the last one is how do you optimize for speed? And so something that we didn't talk about during the demo, but the structure and the index I put on those tables was actually not very strong. So I put a heap index because I just want to get the data written, and I did a round robin distribution because I just want the data to land to disk as quickly as possible so that loading job is finished. And then I do a transformation anyway to get it into my production table, so there's no real cost to me in that regard. So it's how do you load quickly is the biggest thing to think about when you're in the cloud. So we built that. So just to kind of go over the ADLS schema or the file directory that I had, it was a table name head directory, and then per year, per month, per day, and then a set of files. So that's why I was focusing on the month before, but I could have done day if I wanted to. I could have done year. It's really up to you of how big of a chunk of data are you going to start moving. Do you want to update it in the source?
So you've got rows going into your, more data going into your Hadoop cluster.
Yep.
And you want to just keep that.
Yeah, so
Trickle that into your relational.
Yeah, so that's a cool part. So the question is, can you just continue to import it, basically?
Yeah, do I then you have to drop the partition?
Yep. So if the external data source points, say, at the month directory and new rows are coming in, every time you run a load job or run a select statement, you pick up the new rows.
So it doesn't just say trash the whole lot, have another go. It's smart enough to work out.
No, you would have to trash the whole lot and pull up another load.
That's the
Yeah.
problem.
Yeah, but the assumption is because remember you have that loading or that batch-based job running in the background, so you know that, okay, that batch is complete. Now I can do a load. So it's not as tricky as you would think, because it's part of a process, and it's just the second step. You do the extraction, then the loading, then the transformation. If you realize you did another extraction, well, you have to roll back your load and transformation. That's just kind of the unfortunate fact at the moment. So yeah, so think of the ELT scenario for SQL Data Warehouse. It's slightly different than a relational OLTP database where you could do ETL. So yeah, load is optimized for speed and resiliency. It's a real key thing that if I can drive anything home, when you think about anything in the cloud, resiliency is a key. It's a way to get the best performance, the best bang for your buck out of it. So Channel 9 Virtual Academy, I also want to do a big point to user voice. I don't know if you guys have used that. User voice. So if you look up SQL Data Warehouse user voice, I have a SQL Data Warehouse user voice. You can basically submit and ask for any feature that you want in the service. So when you guys start using it and start doing that, I look at it somewhat religiously. And by somewhat, I mean extremely religiously. It's a huge value to me to try to go to my engineering team and say, hey, 68 people asked for this. Like, this is actually valuable as opposed to what I dream up on my desk when I'm thinking about how to load better. My entire team looks at it. Also, MSDN and Stack Overflow, there are SQL DW and PolyBase tags. I look at those religiously. I actually have those all emailed, forwarded to me every day. So if you have any questions, if you have any stumbling blocks, those are two avenues. You can also email me directly at cakarst@microsoft.com. I don't know every answer about SQL Server, SQL DW, data systems as a whole, but I can find people pretty quickly for you. So just get in touch with me, and I can try to solve any problems that you have. So, yeah, that's no problem. So we have a couple minutes I can either finish the demo, now that we're actually working, or we can just answer questions and have a discussion about stuff that you guys are facing today. Perfect.
Start doing an exploratory analytics.
Awesome.
So we fit into that. You remember you had your slide where it started with data generation and then load, and then there was a cleaners after that.
Yep.
Put it into a data warehouse. We're probably more interested in looking at it at the unclean stage.
Okay.
Just to throw stuff into it.
Yeah, just to get the initial analysis of figuring out what can we figure out.
Yes,
Is that the case?
Okay. Users that we would have doing that would be sophisticated enough to write T-SQL.
Mm-hmm.
Typically wouldn't have privileges to be creating tables. So for an organisation like us, what would be the best way to use this sort of technology?
So the question is, you guys aren't necessarily going to do the cleaning space, but you want to have users be able to create tables and actually query that data. Is it do you have a Hadoop cluster today? Is that where the data is going to land?
Not yet, but that's something that we'll be looking at.
Okay. So you could set up a generic set of tables, would be an option. So you create the external data source, and you create the external file formats. You could set up a generic set of tables, because if you know the directory structure the data is going to be landing in, you can create them ahead of time, and customers can just query them as if they're local tables. The thing I would wrestle with there is, like I was saying, if all of your analysts write the same query, say select star from that external table, you're going to load it into the data warehouse every time. So if you know that there's a reasonable subset of data that everyone's going to query, it may actually be more performant to load the data into SQL Server rather than having ad hoc queries run against it. Okay. Just something to kind of play with as you start thinking about the performance tuning of it. But yeah, so pre-creating external tables may be your way to go.
PolyBase cause concurrency issues against the Hadoop clustering if people have lots of queries
No.
against the same bits of file?
No, so we actually hold PolyBase to the same concurrency limit we hold SQL DW to, which is 32 concurrent PolyBase queries. So you're not, flooding the system over there. But you can queue up within the MapReduce resource manager. So it's batch-based, so you can only run so many at a time. So they just sit there in a queue, and then when your turn comes up in the queue, your query runs and returns a result set.
So a user might just eat SQL, they might go, looks like I'm blocked.
Yeah, there's a very real chance that could happen. But you can always go to Resource Manager, which is a UI tool within your Cloudera, or within your Hadoop instance. And you can see, oh, I'm here on the queue. I'm just waiting because there's 10 other people, 50 other people before me.
Are there any considerations around, I guess, standard SQL considerations around working with large volumes of data and things like temp DB or anything different that needs to be considered in this situation, or is it just
I've- Just standard SQL stuff. I've never seen anyone really run into a temp DB issue within SQL Server. You can do that in SQL DW. Yeah, okay, yeah. If you're trying to do the multi-terabyte load into SQL DW, temporarily it lands into temp DB. And so you can knock over temp DB, which is another good, nice point about doing those loops, is you can flush out temp DB, you can flush out the transaction log. It just breaks it down into reasonable chunks.
At the moment, I'm only increasing the number of data warehouse units to circumvent the MDB issue a couple of times.
So you scale up, and then you run whatever you need to run, and you scale back down. Yeah, that's another way to get around it. So TempDB scales linearly with your DWUs in the cloud. And so your resources actually get bigger as you grow, and so does the memory associated with it in TempDB size. I don't know the exact figures, but it does grow.
You scaled up to like 6,000 DWU,
Yep.
but then you weren't actually running anything. You're not going to get charged.
You will get charged for it.
You will get charged even though you're not using it like hourly. It's not.
Correct.
just how
It's
long
existence.
existence
Yeah,
hours?
it's existence hours.
Resource allocation to you, so that's why they charge.
Yeah, we actually like provision your VMs, and they're sitting there. And so,
because it's dedicated to you, right away.
yeah, exactly. You can come in and just run your query, and it goes. But there is a functionality within SQL DW to pause. So you can click the pause button on the portal. You can do it through PowerShell. But it essentially detaches the compute piece of it. So those go away, and now you have all your data stored in your MDF and LDF. And then you resume it, and you just bring the compute clusters back.
Because that's the big difference between data warehouse and one of the big differences between data warehouse and SQL. Azure SQL DB is Azure SQL DB. If you want to scale it, it takes a while to scale.
Yeah.
Data warehouse is instant, like 2 seconds or something.
It's not that fast. Oh yeah. That was a
Like starting point, 2 seconds.
yeah. Can you send me an email about that? Because I've been trying to get that changed for a while.
I am right. It does say that.
And it says in seconds. Yeah. In best case, it's seconds. I've noticed a few minutes.
But you could auto scale it, right? You can get to auto scale it.
You always have to drain the queue. So we can't actually scale with a transaction running. So you have to let all the transactions die, and then we have to scale it. And depending on how your data is actually distributed, there is data movement involved. And so it can take time. A fresh, clean one with no data, yeah, it can probably go in seconds. I mean, I haven't done a head-to-head test. Yeah, an hour is a bit rough. It's faster than Redshift for sure, because Redshift actually has to decommission your stuff and then recommission an entire new one. So I've heard on large production ones that takes days, which is painful. I've never done a head-to-head with the same amount of data. Any other questions while we're hanging out? Thoughts, concerns? Cool. Thanks, guys.